In this example, we're going to use similarity to solve an application problem. Solve the following application problem by determining and using scale factors. Let's get the highlighter ready. Christiane has a full-size tree and a young tree in her backyard. She wants to know how tall the full-size tree is, but doesn't have any way of measuring it because it is too tall. She notices the shadows of the tree and realizes the ratios of the shadow height to the tree height are proportional. Let's highlight that. She measures the shadows and the smaller tree and makes a sketch of the information below. Okay, so this is a common application problem using similarity when the sun shines on objects from the same direction. The taller the object is, the longer its shadow would be, and which makes sense, and it turns out that these values are actually proportional. So I'm just going to draw the figures of something more geometric here. You could think of these as triangles where this is the height of the tree and the shadow is 2 feet. And this is just a bigger triangle that's proportional. Okay, these aren't the best triangles I've ever drawn, but you get the gist. Where this side is 5 feet and this side is unknown. Okay? And since they're proportional, there's going to be a scale factor from one to the other and vice versa. So we're going to find the appropriate scale factor and use this information to solve the problem. So let's look at the next slide. For which type of measurement, shadow height or tree height, do we have information on both of the trees? Well, so notice we're given the shadow height for both of them, but we're not given the tree height for both of them. We want to find the tree height for the taller tree. So we know the shadow height for both trees. And this is important because remember, we want to find a scale factor. So we want to find either what do I multiply 2 by to get 5, what do I multiply 5 by to get 2, and we need both of the numbers in the corresponding figures to do so. So that's why we want to zoom in on the ones we know. So now we're asked, using the information from the diagram, find the scale factor from the young tree to the full-size tree. Okay, so we're going to use these shadow heights, and we want to go from the young tree to the full-size tree. So we ask, what do I multiply 2 feet by to get 5 feet? Okay. So again, thinking of the broomsticks, how many times as large as 5 feet than 2 feet? Well, it would be 2 copies of 2 feet would be 4 feet, and another half a copy. And we can think of it in terms of this as we would take, our question mark is taking the 2 feet, dividing it by 2, and then multiplying it by 5 to get 5 feet. So our scale factor from the young tree to the large tree is 5 halves. And again, notice 5 halves is 2.5 times as large. So this shadow is 2.5 times as large as this shadow, and that makes sense because this is the taller tree and the bigger shadow. So if you had written 2/5, then that would be the scale factor from the large tree to the small tree. Okay? Now use the scale factor in the height of the young tree to find the height of the full-size tree. Write your answer as a complete sentence. So let's go ahead and change this scale factor to a decimal. I'm just noticing we have a decimal here, so that will be easier. So to go from the height of the small tree to the large tree, we'd multiply 4.5 feet times the scale factor. This tree is 2.5 times as large, so I'm going to multiply by 2.5. And let's use the calculator for that. 4.5 times 2.5 is 11.25. Okay, And again, I just like to write it on my diagram and see if everything seems to line up. It's 2.5 times larger than 4.5, and that makes sense. So our answer as a complete sentence is what are we calling it, the full-size tree? The full-size tree is 11.25 feet tall.